Good afternoon, everyone. Welcome to today's CECAN webinar. My name is Ben Shaw, and I'm Deputy Director of CECAN. For those of you who haven't joined us before, CECAN is the Centre for Evaluation of Complexity across the Nexus. Since 2016, we've been working on transforming the practice of policy evaluation across the food, energy, water and environmental domains to make it fit for addressing a complex world. We've been achieving that through pioneering, testing and promoting innovative policy evaluation approaches with a range of UK government departments and evaluation practitioners and consultants. And there's lots of information and resources on our website at cecan.ac.uk. Today, seminar is going to be focusing on developing system approaches in the water sector. And I'm very pleased to welcome our speaker today, Brendan Bromwich, who is Principal Engineer in Asset Management and Investment Planning at Mott MacDonald, and is going to speak about developing systems approaches in the water sector. Brendan will speak for about 40 minutes, and at the end we'll have some time for questions. And if you have questions, please submit them in the question box, which you should see at the bottom of the Zoom webinar control panel. And just say we're recording the webinar and it'll be made available shortly after we've finished the webinar, along with the presentation slides. So hopefully that's all clear. And with that, I'll welcome Brendan and hand over to Brendan for the presentation. Thank you.
Great. Many thanks, Ben. Many thanks, everyone. Looking forward to the discussion this afternoon. Great. I'm writing this presentation. I thought I would just try and summarize it and let you know at the beginning what it is that I'm saying, because we do jump around from different topics, but I think they hang together. So understanding systems enables a transformative rather than a piecemeal intervention in interventions in the water sector. At least that's the promise of us taking a systems approach. That's the objective. You can map systems, and often that's useful, not always, but the approach needs to be well targeted. It can be done well, it can be done not so well. You've got to get it right. Different organizations have different implicit assumptions about systems relating to the handling of uncertainty and risk. And this is really key, because it's not just that this means that in understanding a system, you're going to have difficulties. You just don't understand why you don't understand each other, and you're spanning different boundaries from different disciplines and so on. But also, once you do get there in terms of understanding these implicit assumptions, then you'll be better able to understand how uncertainty is dealt with, and that opens up a range of opportunities for dealing with risk. And so these cultural preferences that different organizations have are significant in collaboration and in designing governance arrangements. So the aim of the talk today is we'll look at systems mapping, we'll look at different approaches to systems, and then we'll see what we can learn about uncertainty and risk, and how different cultures of different organizations can be mobilized for better governance. So why should we think systems? I've put some some of the problems that we're facing on the left, and some of the ambition, the opportunities we've got on the right. So there's a widespread acknowledgement that linear interventions are failing. We haven't managed to halt the decline in biodiversity. We haven't got on top of flooding. And part of the problem is we're not tackling things across the board. So systems would be an appropriate approach. Resilience and adaptation, there's the risk of failure. It's not just a matter of growth, and therefore we've got to understand what could go wrong, and that's a lot of different things, and they could happen together. So understanding systems helps there. Non-stationarity and complexity, there's more unknown unknowns, and we saw this in terms of some of the approaches coming together with the pandemic and a drought, well, very high warm weather at least, happening together at the beginning of the outbreak of COVID. And it's more cost effective if we take systemic approaches. Then there's growing ambition as well. So this is a positive. People are thinking more about the social outcomes of infrastructure. and there's more data available. Digital provides a platform to tackle some of these things. And what's interesting now is the opportunity to reach out to other communities asking the same question from different vantage points. So you look at the Task Force for Climate-Related Financial Disclosures, they're asking questions that environmentalists are talking about, and that's a finance community. So we think systems would be able to bridge some of those gaps better. There's a lot in policy which is driving this, the 25-year environmental plan, natural capital approach and resilience in the round, and Ofwat's subsequent work have all been driving for a systems approach in order to get deeper transformative change. And given that so many people are tackling similar work, there's common languages and common frameworks that we can build on. So things like the multi-capital accounting, the capital work of the Capitals Coalition, the 25-year environmental plan, Project 13, and so on. We've now got language that we can draw on to bridge some of these gaps. So just a few examples of systems. This is the multi-capital accounting from the IIRC. Interesting here, this is very much from the perspective of business. They look at a system and say, what are the opportunities? What value creation can be done here? And you can see in the middle there's inputs and then activities and outputs and outcomes. And so there's a lot of very familiar language for people working with systems, but this is systems through a business lens. Here is a process flow diagram. So this is a water treatment system, and you can see different elements of it. It's a different animal. It's still a system diagram, but it's a different animal from the last one that we've seen. Here's another example. This is the Axios Delta strategic plan in Greece. And you can see this green section in the middle is a list of goals for the Delta. And then there's a whole range of problems that you've got in there, the orange cells, and then white cells are activities and types of intervention. And on the bottom left, you can see a results chain. And what's interesting about this is it looks like a comprehensive approach. It's really designed to control what's happening in the Delta, but it doesn't quite add up given that it was created in Finland rather than in Greece, and therefore it's a recommended strategic plan. So when we dig in a little bit here, it looks like a kind of community-based or participatory system map, but actually it isn't. So I think I just put this one in to kind of flag up, you know, there's an idea around control here, but you've got to ask the questions, dig a little deeper and say, well, who produced it? You know, what is the ideas around control? By contrast, here's one from South Africa, which had a very extensive community engagement process with a lot of workshops of the type you can see on the top right. There's a digital kind of communication strategy, then a causal loop diagram. And there's a range of causal loop diagrams like this one, and it's backed up with GIS layers. So this systems map is quite a different animal from, for example, the water treatment one. This one's really got a lot to do with stakeholder engagement. So this then to kind of flag up the different approaches people are taking. Here's a piece of work that we did for Water Resources Southeast for their resilience framework, and this is using a participatory systems mapping approach developed at CECAN. And here what we've got is where we have a green line. All of these nodes can go up or down. And where you have a green line, A goes up, then B goes up. Where you have a red line, A goes up and B goes down. So you can see that river restoration activity goes up, you get better channel morphology, you get more connected habitat, and that leads to healthy rivers. So that would be an example, and blue is a more complex link. So this is another type, and we'll be showing a number of these maps shortly. So the kind of main message here then is there's lots of different types, and you need to understand the purpose and the context and the culture around them. A couple of years ago in 2019, 2020, Mott MacDonald and CECAN undertook a project for Defra to kind of flesh out what does it actually mean in practice to do systems mapping, and we used a participatory systems mapping approach in the Eden in Cumbria and the Medway in Kent and Sussex. And it was really about getting proof of concept for a participatory systems mapping approach, and you'll find this report on the Defra website, identifying different ways of intervening in the catchment. We mapped hard systems and soft systems. We'll come on to that, and we developed an approach that can be replicated elsewhere. This is the outline of the approach. We basically used 3 workshops, and during the workshops we developed the map, and then over time we shifted towards analysis of the map, but there was some feedback to the system development. And then the idea is that you're able to kind of consult each of the stakeholders, each of the participants is able to liaise with their constituencies, and by this way you're really able to kind of get more engagement with the development map. And what's really great after this is that you have a systems map that has been validated as it's been built, and then you're able to use that in analysis of trade-offs or of intervention points or of objectives and so on. So it's a very powerful process, but it's as much a stakeholder process as it is an analytical process. These are the maps that as they developed, and we drew some of the maps out and produced sub-maps to do the analysis, and I'd refer you back to the excellent presentation that Alex Penn and Pete Barbook-Johnson made in this series a few weeks back for more detailed analysis of those maps. We, just to kind of summarize, well, what did we learn? In the Medway, it was very interesting to look into the detail of the contrasting development pathways. There's a lot of transport and logistics is important there, as is agriculture. And in some ways they compete, and in some ways they're complementary. And so we were looking at different ways that you could intervene to put the agricultural development on a positive trajectory that was supportive to the logistics, and prevented. If you improve your soil health, you're mitigating some of the problems of flooding that some of your urban development is developing, and so on. So we looked into detail on some of those, and we also looked then at the Eden. And in the Eden, it was interesting. We didn't have the same interface between urban and rural as much as we had in Medway, but we had a lot more on farmer behaviour and understanding if farmer behaviour is crucial to the outcomes that you want to develop in a catchment, what are the influences of those? And you need to understand then the significance of tenancy and inheritance arrangements. And we found that having a trusted advisor was going to make a big difference in uptake of new agricultural processes. And also we found the significance of farmer to farmer instruction and cultural change, bringing changes in practices. So 2 different approaches. But there was one question which came up around this nature of systems, and that we took hold of. And that was this. I mean, apologies for the very bright slide. I spent some little while trying to change the color on the template, but actually this was very, very significant. So I decided we'd leave it. When I talk about catchment systems with Highways England or Network Rail, I don't feel I'm on a level playing field. And what we decided to do in the project was to drill down and try and work out what was behind that statement, and why was there this sense of not being in a level playing field. So we looked in different ways about, well, what are the implications, what are the assumptions around systems, and the narrative that the catchment, people working at the catchment level are coming up with a different narrative with Highways England and Network Rail, who are talking maybe more specifically in engineering terms. And part of what we did here is we were very fortunate. We had a very useful kind of contribution from the Environment Agency's work on systems water management for catchment scales processes, which you'll find on the EA website. And they had this map, which we found quite helpful in terms of looking at hard systems and soft systems. So on the right, you'd have a hard system, and on top you've got what's actually there, the environment, and the people are actually there, the stakeholders. And on the bottom, you've got the systems representation of this thing, and that includes kind of physical models, maybe your ecosystem service mapping and so on. And on the left, you've got the perception of the stakeholders. And both of these are important. And what you've got when you're looking at systems, if you've got different degrees of emphasis on the right hand and on the left hand, and you've got different degrees to which stuff that comes in on the left hand is admissible in the debate, or whether actually some people would be saying, well, on the left hand, these are the real experts, let's go with that. And so there was a live discussion around that. And this seemed to be relevant to our participants' comment. And so we looked out at what are the different elements of all of this. And if you want, on the right, we've got the kind of harder end of the system. And on the left, we've got kind of maybe more the softer. And you'll see these terms, community and egalitarian, or formal and bureaucratic, and we'll come back to those later. So in terms of admissible data, as I say, more relevance to stakeholder perception on the left, more of a focus on engineering and science on the right. So who validates it? I mean, on the left, you'd say the stakeholders, they're the real experts. And on the right, well, in harder systems, in terms of your design of your water treatment works, well, it's not so much the stakeholder interest, it's more where you want a qualified engineer for that. And then how would you map this out? Well, you know, participatory systems mapping works very well on the left, and on the right, well, maybe you'd be more interested in an engineering drawing for a harder system, or, you know, your ecosystem service mapping, or natural capital mapping, or whatever it is. And what's interesting here then is this then begins to have some kind of implicit implications for who would operate this. And on the left, they would say, well, it's a community assessment, a community-based kind of project. You've got to have the stakeholders involved. Whereas on the right, you know, if you kind of, on the right, one of the interesting things on the right, people talking in these terms would use air traffic control as an example of a system. And you want air traffic control, or you want railway signalling done by somebody who's an expert in this field. And then in terms of that knocks on, as I say, to the complied control system. And then we look down to unknowns. On the left, we can accommodate uncertainty a little bit more. And on the right, we would more be looking at kind of defining risk values and doing more calculations, kind of harder, kind of analytical work. And then we'll just jump on before we come back to this example relevant to the UK. We could put one in the middle by pointing out that you could have a blended approach, and that, you know, the Limpopo project was a brilliant example of blending both the stakeholder perception and the physical modelling, and the EA kind of framework had that. What's very interesting here then is how those perceptions around systems are reflected in three different groups working at catchment level. One's the environmentalist, the EA's asset performance team. So there's the engineering group in the Environment Agency. The next is the flood partnership, who are a partnership between the Environment Agency and catchment-based stakeholders. And on the left will be a catchment partnership. So you would have more of an egalitarian approach amongst the catchment partnership, more emphasis on participation, whereas on the right you'd have more emphasis on engineering, planning and management and so on. And the flood partnership sit between the two. A piece of work that the environment, sorry, I've got key observation. So there we are, the organizational culture influences how you perceive and articulate a system. And just to kind of follow on there, that a piece of work that the Environment Agency was doing around this time was contrasting the organizational cultures and contributions to the management of catchment systems by talking with catchment partnership. And it was interesting that they perceived themselves of having an advantage. They could do things that the flood partnership couldn't, because they were a third-party sector, and they had a convening power as a result of not being an agent they weren't implementing in the same way. They had more reach to mobilize collective action. But they did look across at the more formal organization in the flood partnership and say, well, for example, partners have ideas for what they would like to do, but the mechanisms for making it happen are not there. This is because the representatives of the partnership don't have the right level of seniority to make changes in their organization. So they did look across, and you can see this in some of the comments below. The strategic group in the flood partnership has a high level of personal commitment by senior representatives at CEO level, elected members, and senior directors attend the strategic group. And here we are again. The flood partnership has written published plan with clear responsibilities, who delivers what. Members have a specific role and are held accountable for delivering it and report back on the activities of strategic group. So there, it's interesting that they're acknowledging kind of relative merits of a more hierarchical approach or a more egalitarian approach. And this is part of how they understand different systems. So it's their organizational culture that bears this out. Yeah, so there's a summary of what we've just been saying. And just want to put this into a kind of theoretical basis. In this, I mean, part of this is the idea around embedded decision making. That on the one hand, I think particularly as engineers, we do analysis on cost-benefit analysis. We assume a rational actor. We assume maximization of benefit for least cost. Whereas actually, when it comes to it, decision making is embedded. We're informed by the cultural norms around us, and so we can see that there's the degree to which we're prepared to engage with this embedded nature of decision making will mean that we will reflect stakeholder perceptions. So I just want to put that out there, and it's very interesting to see the Descriptor review kind of drawing on this in terms of this theory. Another part would be to think in terms of wicked problems. So this is a very interesting paper written to talk about how some problems are tame in that you can define them and you can find a solution and you can answer them. But some problems are much more complex than that. So for example, climate change or how to manage a catchment. There's no definitive formulation of a wicked problem, and the search to identify that formulation is part of the problem itself. So in a sense, it reflects our bias that when you, as an engineer, who might be inclined to be towards an infrastructure solution, or an environmental NGO would be asking the question, well, who should we be collaborating with in order to solve this problem? Or the private sector would be saying, looking at this problem and saying, well, we can solve this with technology. There's a technological solution, we can innovate and so on. And that's the idea of a wicked problem, is that you can't actually nail it down. You need to have the benefit of different perspectives in order to address this problem. So I just want to leave that on one side. We've introduced those ideas, and I want to jump now across to a piece of follow-up work we did for Water Resources Southeast. And so we've got a little case study here. With the feedback on the draft resilience framework for water resources had these kind of three kind of key ideas: that it needed to be, the scope needed to be more than the public water supply system, and it needed to be broader, bringing in other elements. There needed to be more of an emphasis that the environmental system was the foundation of everything that was going on, and there needed to be greater kind of rationale in systems terms for the resilience metrics that we were using for the investment plan. So Water Resources Southeast, what it is it's the regional plan to develop a water resource strategy for the southeast of England from 2025 to 2100. So what we had was 1,400 options for projects put forward by the 6 companies of the Southeast and a wide range of other partners, such as different sectors and catchment management groups and so on. And we needed to kind of look to see what benefit that they would bring with regards to resilience in the water resources. So we needed to work out, well, what does resilience mean in general, and what does it mean in this particular context? And we had this schedule of metrics in order to show whether an option would enhance its reliability, its adaptability, or its evolvability of the overall water system. So what we started off by doing was kind of saying, well, what is, well, first of all, we define these attributes. Reliability is an attribute that means the system can maintain its original function in face of shocks. So put a flood defense around the water treatment works. It's a passive form of resilience. Adaptability is an attribute that means the system can undertake a short-term modification of its function to withstand a shock. And so if your customers engage well with the water company and observe hosepipe bans, that's an adaptable strategy. It can adapt to the shock and it will kind of recover afterwards. And evolvability is an attribute that enables the system to modify its operation in face of one or more stresses or trends. And for example, we looked at if a new pipeline, if water could be pumped both ways, because the pattern of drought in the south, across the southeast may be different in future than what it is now, then that is a more evolvable system and therefore more resilient. And this is kind of a modification of Bolt's and Brown's work on resilience. So, but what's interesting here is these are, of course, all system functions. So when you're talking about resilience, you're talking about a system. How does the system respond to shocks and stresses? That's the key question in resilience. So what we did is we started this systems map exercise, and here is a systems map with a big feedback loop. And I'm just going to run through this one very, very briefly. If you start off here with a competent company, they will do resilient engineering operation, provide resilient engineering infrastructure, and maintain a resilient water source, which will provide a resilient supply to customers. And that is one side of the supply-demand balance. You will also find customers are active in demand management, and that's the other side. Now, if this is achieved, this is the main function of this system, then businesses will have water to operate and the population has health and well-being. But also, there's the feedback loop, is the company has the confidence of the regulator trusts the company, allows innovation, so you get a more creative strategy and you get a feedback loop like that. So what you find then is a great big positive feedback loop in the middle of this. And this was our starting point of the systems map. I've just kind of compressed it there to make it more legible in this one, and then we'll jump forward. What we did is we started putting those resilience metrics onto this system so we could see where they were, and then we could see where they needed to be moved about. And we put on the shocks and stresses, and then also we developed it in order to kind of show the environmental system. In fact, we had 13 maps of this size showing different elements of the environmental system and different multi-sector systems. And this was one of the maps about halfway through the process where we were reorganizing the metrics to make sure that the different shocks we've been looking at were properly represented. And there's a degree of crowding around infrastructure, but it wasn't overcooked in any particular area. And kind of 3 new metrics came in on this basis. One is, this element of good customer relations leading to active demand management. So good customer relations makes your water system more resilient because people do obey their hosepipe bans and so on. Another one was soil health, because soil health is important for many different aspects of the environmental system, which underpins public water supply. And so as part of the big debate, when we really had to come to terms with the environmental, farming is upstream of the public water supply system, not downstream of the public water supply system. Irrigation is important, it is downstream, so that's significant. But the big element here is that farming is upstream, and engaging with farmers is going to be critical, because that's where so much of our water comes from. And then we had environmental land management was another one. So what did we learn from this? I think this work with the metrics worked very well. I think we had some other elements of the public water, of the multi-sector system, where we didn't get much buy-in, and I think perhaps we were over-ambitious in some places, although there were some groups like around the discussions around canals and Gulf water use, where it was more useful. There were some where people didn't really engage. So I think the rationale for participatory systems mapping has to be clear and robust, and only undertake it if everyone's bought in, because if you're left trying to kind of update the map away from the conversation, you've lost it. Whereas if the map is where the conversation is, then you've really got something useful, because you've got an audit trail for what you've been discussing. And I think it's very useful in validating metrics and understanding resilience, but it needs to be part of a broader discussion. So where are the good places to do system mapping? Metrics, as I say, and Water Resources Southeast and Northumbrian Water, where we're doing some work with them. Identifying interventions. We've had a successful project looking at the Fenland Reservoir, and if you understand the system, then you can look at different ways that interventions can move onto it. And here's a really interesting one around, building on that, is co-benefit and attribution. And we're looking at this in the Innovation Festival for Northumbrian Water, where we're doing a scheme, looking at a scheme on phosphates. So if you do your systems mapping and you work out what are all the things that would kind of address phosphates, and kind of your buffer strips and your soil health and cover cropping and so on, well, then you can say, well, if we do those upstream interventions, what are the other benefits that we get downstream? You get things, you're moving towards natural flood management, carbon sequestration, biodiversity, and so on. And then you can ask the question, well, if we're doing these things upstream, who else would like to get those benefits from what's happening downstream? And then we've moved from a kind of linear intervention, a project-based approach, to a catchment transformation approach. And a good systems map will help you work through the attribution of those benefits, and that will set up the basis by which you could set up a blended finance approach for this. So that's one of the real promises around systems mapping. And what you do is you've then developed an audit trail, and where for this complex narrative, and that's a very significant kind of contribution in all of this. Currently, we're developing a project around some of the trade-offs on highways, and one of the benefits is going to be the audit trail. Then it's very useful in developing frameworks. So we've just been appointed to do the integrated water plan for the Oxcam Arc, and we'll be looking at different sectors and how they use water. We'll be looking at the flood strategy, the water resource strategy, the water quality strategy, and how these things are interrelated through this. Then also very useful in impact evaluation, which is important for natural flood management and landscape interventions. It's very interesting how much the international development sector has actually done on systems approaches and evaluation. So there's much to learn there. I'm keen to crack on here. So just quickly want to run through, I may skip some of this. Within the Water Resources Southeast, we found that we reviewed the multi-sector approaches to resilience. Power were best placed to work out the risks and the costs in order to mobilize finance. But they wanted a really robust, they didn't want to trade in order to get water, because they had to have absolute assurance that they were going to keep it. Paper were quite similar. Rain-fed farming was different in that they had very high tolerance of variable outcomes. So wheat production had dropped by 40% between 2019 and 2020, And that's because it trades on the open market. So it can tolerate, there's no knock-on effect from one to the next. Whereas on the other hand, protected farming has a low tolerance of crop failure because they have knock-on effects from one year to the next. So they are more interested in connecting with the public water supply. Canals have a clear strategy of a 1 in 20 year service, but they're diversifying their revenue streams at the moment. And golf has problems with a cultural change that people are not willing to take up. So it's very interesting. They've just started a leisure association with the Water Charter in 2021. I'm just going to jump this to say the basis for cultural theory. Cultural theory, just briefly, if we were to look at society and you've got folk who are more compliant with rules and norms and people who are less compliant with rules and norms, then you would end up with government on that top right sector who would be risk controlling, environmental NGOs on the lower right who are risk pooling, the private sector who are risk capitalizing, and on the top left you'd have risk accepting. Engineers would also be looking to control risk. And this is a bureaucratic or a hierarchical strategy. And on the bottom right being an egalitarian or collaborative strategy. And on the bottom right is entrepreneurs. So you can see here that these are different approaches to systems mapping have been represented in these. So we can map onto those that are different sectors, power and paper on the top right, but they also have an entrepreneurial aspect, canals, sort of rain-fed farming on the top left, and golf on the top right, on the lower right. But this is the one I wanted to look at then. In terms of the Water Framework Directive has taken an approach at the catchment level that sets out the control structure, the regulations. Whereas on the bottom right, CABA has enabled a more collaborative risk pooling approach. And on the bottom left, you can see Payment for Ecosystem Services is an approach that brings in that entrepreneurial element. So we've got 3 different risk approaches reflecting 3 different approach biases towards systems. And just to quote Tony Allen, who said that good governance is when .gov.org.com work well together for society. And those are the 3 sectors we've looked at, with society being the top left. Skip this slide. Okay. So what does this mean then at the national level? It's very interesting. As you move water around the country, you've got a simple system, relatively speaking, a tame system of concrete, water and finance, which can be controlled and optimized. But that needs to interface with a more complex system at the lower level in catchments, where if you intervene and you optimize a catchment for, say, water resources, you may be causing problems for biodiversity and so on. So we need to find a way of managing those different levels of different types of system. And that is going to need all of those different risk management strategies in order to achieve them. I'm just going to jump over the landscape enterprise networks, is one of the ways that this is being done. Just to kind of on my final slide then, before the conclusion, is the United Utilities catchment systems thinking. And just to highlight, you've got a real issue around when you're contracting for services to be done. For an NGO who's best placed, their DNA is pooling risk, they may find it more difficult to be contracted for outcomes. And it's interesting to see United Utilities are tackling this, because United Utilities are retaining the risk. For example, in their River Petrol project, they retain the risk because they're funding activities and outcomes rather than impacts. But that's still better than the extra cost of producing modifying their wastewater treatment works to get the same results. Because by taking that risk and allowing that variability in outcome, it's still lower cost, lower carbon, and has more co-benefits. By contrast, in the River Wye, you have a wide this is a project with a wide range of benefits. What they've done is they've set up a SPV to take out a loan, and they have a staged transfer of risk. In the first half, they're funding the outputs, but then the payments in the second half of that nine-year project is more on outcomes, by which time they have worked out that the risk has been transferred on the basis of experience. So I just want to kind of flag that up as this risk based analysis is a way of designing governance of systems, as well as being a way of understanding why different organizations take different approaches to different systems. And that makes systems mapping collectively a lot easier as well. So thanks very much. I'm sorry I had to rush that a bit, but it gives a little bit more time for questions.
Great. Thank you, Brendan. I'm sorry, I'm just resting the video. Yeah, thank you, Brendan. That's great. My video doesn't seem to be coming on now, but I'm not quite sure why. Really interesting. Obviously covering a lot of ground with a big system. I think that's perhaps one of the interesting things is how we all have our individual systems which we're quite good at managing, but it's when you start interacting with other people's systems and it's those managing those processes. We've got one question. Do put your questions in the Q&A if you have questions. Can I kick things off, perhaps, Brendan, with a question about this work was you had Environment Agency was one client and WRIC was the other client. What do you feel how did their approach to systems develop over the course of these work? Do you feel there's quite a lot of interest in systems, but do you feel their approach to systems thinking developed and they saw key benefits from this?
Yes, I do. I think the Environment Agency, I mean, they're great. They're doing a lot of work on systems, and you'll have seen a more recent report that's come out mapping the water quality in the Lake Windermere. So they're really driving this approach, and I think that's excellent because catchments really are complex systems, and I think there needs to be quite an informed discussion around systems, because for the Environment Agency, they've really got to tackle this question of soft systems as well as hard systems. Whereas when we're working with the WRC, who also kind of really got this, I think what's been interesting is within any one organization, you will have people who are more up the catchment management side who are kind of keen to engage on these things, and then there'll be people more on the engineering side who might see, well, look, we can define a solution. And I think the biggest difficulty in all of this is culture, and I include myself in that. It's always a matter of kind of think, we talk with an English accent, we assume we're the only ones without an accent. It's the same with doing systems. As engineers, we might think, well, it's rational what we're doing, but they don't realize that itself is an accent. And for me, the difficulty, I first was confronted by this in a project in Sudan, where I had a consultant who was producing a report on livelihoods related to water. And I was really struggling with the fact he wasn't kind of taking the hydrology seriously enough. In the end, he produced a report on livelihoods. It was very, very useful. But it was quite a difficult learning curve for me to kind of let go of the fact, no, he's got to get the hydrology, he's riding roughshod over the hydrology. So I think in both cases, I think, WRC were great. I mean, they kind of backed this approach, and in the end, we produced something which validated their metrics, and that was very helpful. And they showed, well, actually, just by producing a table, they didn't have that validation process. So I think, both organisations were great, and I think EA have gone a very long way in this way. But in any organisation and in any person working in systems, it's really a matter of saying, look, somebody else sees this thing completely different. I've got to understand what the benefit of that is.
Great. Okay, questions are, I've got more questions I asked, but questions are flooding in now. I've got 3 in the Q&A and 1 in the chat. I'll go with the, there's a general one in the chat from Aridi Galu, asking if you can share any more information about the Oxcam artwork. And she's interested in applications on co-benefits are relevant to our work as well. I'm coming from Historic England, keen to work with systems approach on historic landscape management, stewardship, and stakeholders engagement in contexts like national parks.
So I can't share any more on that project as yet, because it's just a kind of earliest stage. But in terms of, you know, how to kind of integrate with historic landscapes and, you know, just the breadth of different kind of issues of interest, I think what's particularly interesting is about where do you define the boundary of what you're looking at? Because if you define so the project relates to, I think it's kind of the core systems around flood management and water resources and so on, and water quality. But if you just look at those, well, you'll end up with kind of boundary effects. You've got to understand the system beyond it. So in the Oxcam arc, you've got to understand the knowledge economy, which is driving the development. And it's only by doing some kind of mapping beyond what you actually need will you be able to kind of get a representative driver of, you know, your core systems of interest. So I think I'm sorry, it's not much of an answer, but I think it's going to be a very interesting kind of piece of work, because we've got to understand the context so that we can understand what kind of trade-offs are going to be needed, what kind of pressures there are going to be across the different elements of the water system there.
Yeah, and Brendan, the WRSE works in the public domain, so that's a good way of looking at that, isn't it?
Yeah, I can provide a link for that.
Yeah. Okay, so, go Brendan.
Well, just to say that map has a lot of systems maps on it, and then there's the EA map, and then there's National Infrastructure Commission. And what's really exciting now is that, you know, there's more people doing the systems mapping, and they can have a kind of bricolage. You can take pieces from different areas, and, you know, now we're getting it kind of more established, and then you can say, okay, look, this is what happens generically, but how is this local context different? So I think there's an interesting kind of stage kind of emerging on different systems mapping projects.
Yeah, great. I have a question from Thea Wingfield. It says, hello, thank you for a great presentation. Do you have, or can you recommend any sources of information about your final section about risk management and organization culture?
I can. Mike Thompson's book, Cultural Theory, was very, very helpful. It was actually my lifesaver as an engineer in a social science department. I needed help to navigate the different assumptions I had and the different assumptions my colleagues had, both of whom had unrecognized assumptions, and that framework was a lifesaver for me in that regard. So Mike Thompson's work, and then he's written more in the book we produced together, the Oxford Handbook of Food, Water and Society, Tony Allen's work on the Middle East water question. So Tony, very significant in this area, and in his kind of great kind of observation, good governance is when .com, .org and .gov work well together. So, yeah. But it's actually Mary Douglas's theory, 1986, how institutions think, is the origin of all of this.
Great. Okay. A question from Jyoti Banerjee, G, you'll be familiar with, Brendan. Has systems thinking resulted in verifiable different outcomes from what might have emerged through traditional expert-led approaches? How would you assess whether the approaches are better?
That's a very good question. I think in terms of having, talking about WRSE, I think having recognized that particularly customers and the relations water companies have with customers, because customers are water users, I think that the fact that that is recognized in resilience is a big step forward, as is soil health. So I think that they're actually now used in the investment modeling. for Water Resources South East, I think would be very tangible. There's one really lovely example from the 1960s, the Scamandon Dam, which is on the M62, where there's a dam there, which is the Huddersfield water supply, and it's part of the M62. And basically, it was before systems mapping was done, and we talked with so much jargon. Some engineers managed to have a conversation, and they managed to halve the cost of each project by doing this thing together. And I held that's the holy grail. That's what we want to be achieving, is kind of Scamandon Dam at the local level. And the other examples of systems thinking would be, the Glasgow Smart Canals Network, where the canals are lowered ahead of flood events in Glasgow so that they can accommodate more water. So there's practical things like that, and the more stories we get about this kind of thing, the better.
Great. Question, Defra asks, when everyone has an agenda, who do you think is best placed to facilitate, lead a stakeholder-led systems thinking approach?
So I think that's a really important question. And my answer would be somebody who's not an active player in it. And one set of people who do this very well is the United Nations in their humanitarian responses, where you've got a group called the Office for Coordination of Humanitarian Affairs, OCHA. And in an environment, in an emergency context, OCHA hold all the coordination meetings, but they don't implement any projects. And as a result of that, they're trusted. Whereas, because actually across the NGOs and the UN organizations, there is a little bit of competition for donor funding. That's kind of inevitable. Whereas given OCHA, they don't have a dog in that fight. They have a purely coordinating role. And so there's something of real advantage there, which is interesting because in some cases you want to kind of, if your governance arrangements have that singular kind of risk approach, it's an advantage. But there's other cases where there would be a hybridity that matters. And so, United Utilities and their partnership with the Rivers Trust brings a hybridity which is useful in that context, so long as, well, you use SVP for the coordination and the catchment role. You've got to get the distinction between risk management function in the right place. But what I hope is that, in this presentation, I've made the case for this cultural theory to be one of the frameworks we could use to kind of sort this problem out, identify who's best placed to do what and so on.
Yeah, there's some interesting work which I was looking at in a social setting, which has been very much about the need for, as you say, independent or systems managers and backbone organizations that coordinate and facilitate some of the interactions around systems work. And Bill, I think you mentioned at the beginning of the presentation the importance of purpose. Why are you doing this, and having some negotiation about purpose, and it can be quite an interesting thing. So people, you agree a shared objective at the beginning of a process, and then that helps facilitate development of understanding the system. And the need for some, I guess there's some enlightened self-interest in some of the the water companies sort of moving in the space that they by doing this work they get some of the things which they need to do, but it's it's in their interest to do this, but it might not be in their narrow remit.
So the United Utilities example is very, very interesting there. There's more uncertainty around outcomes through the catchment approach that we were looking at, but the end result is a much more cost-effective way of doing it than building more sewage treatment works. Plus, you get a range of co-benefits.
Yeah. Conscious of time, got a question from Huda Akayami. System mapping here appears to be using first-order cybernetics methods, i.e. systems dynamics suitable to a systems engineering approach. Have you used social learning approaches, e.g. soft systems methodology?
So this might be in a more technical language than I'm familiar with. I can't look at you, Ben.
It's not one I can advise on, but I don't know.
I think, well, I'll tell you what I do know in response to that. I'm sorry not to be able to provide a technical answer. What I can say is that, you know, the element of learning is crucial, and that's why we say when we're doing a participatory systems mapping, it's as much about stakeholder engagement as it is about the analysis, because the people who get most out of it are the other stakeholders, apart from anything else. And so therefore it's useful, and I've used it previously. Again, this was in Sudan for the UN. We used a causal loop diagram looking at the links between environmental change and conflict before we set up our strategic kind of planning for the next round of programming. And we had 4 different groups who had who also all produced different systems maps looking at you know, those links between kind of poverty, conflict, and natural resources. But that was absolutely fine. I didn't want at the end of it people to say they'd cracked the problem, because nobody's cracked that problem. It is a deeply wicked problem. But what happened was that, you know, there'd been, you know, 10,000 conversations that happened over the course of the day between different people who had engaged with viewpoints which were different from their own. And that meant that the second day of the workshop, when we moved into reviewing what we'd done, and the third day working out what we were going to do next, well, producing those causal loop diagrams had been a very instructive learning process. But that was right up that end of the spectrum, whereas of course that's completely the other end of the spectrum for, you know, my, you know, process flow diagrams that I want for a water treatment works, where actually it's the end result is the thing we're going to use for design. So I'm sorry not to answer your question, but I hope that's relevant.
I think from my involvement in the work and observation of the work, there was a lot of the final report has maps in it, but you know, there was a lot of iterations you went through from the initial sort of, this is our first cut, and they developed over time. And then Huda says in the Q&A, you've used soft system methodology in engaging diverse perspectives and accommodating possibly conflicting worldviews. Thanks. So I think you may not have known the technical definition, but you've done that. So
yeah, no, that was, sorry, just to say, that was very interesting in Water Resources Southeast in those steering group meetings, because, you know, not everyone was familiar with the approach, and, you know, that map, the map that I showed was worked really hard over an 8-week period. So, I mean, it had a real depth of analysis behind it. It was a great experience. It was very, very interesting.
Yeah. Okay. Moving towards the last questions. David Furrow asks, where current metric sets poor at describing the system, where they focus on particular aspects of the system, and where the significant gaps. And I might add on to that, in verifying your resilience metrics, were you verifying them conceptually rather than it was a qualitative and conceptual verification rather than a quantitative?
Yes, that's right.
Yeah, don't want to overshadow David's question about the.
Could you repeat, David?
So were current metric sets poor at describing the system, where they focus on particular aspects of the system, and where the significant gaps?
So yeah, I mean, I think so the metric set, the feedback from the first set that was put out for consultation was saying it was too focused on the public water supply. And, you know, as I say, you know, we added these 3 different metrics around customer relations, environmental land management, and soil health. So we moved it in that direction. And I think that I thought WRC were great in the way they handled this, because, you know, it was a huge undertaking. It's a massive strategic planning exercise that's going on in WRC and in the other groups across the country. And, you know, they set the ambition high on the basis of, we want to kind of cover all of the issues conceptually. If we can't get data at this stage, well, don't let that a reason not to kind of put down what is conceptually needed, because it gives us 5 years, you know, it's now kind of 3 years till the next round of programming so that we can look at these metrics and do more work to get the data so that we're ready in 3 years' time. So I thought, I mean, WRC, I think, is great in its ambition and its vision in all of this. And, you know, this systems mapping was an element to try and kind of operationalize that, really building on the work that Defra had funded. It was a very, very helpful to have the Defra project leading into the WRC work.
Great. Okay. Well, we're out of time. So thank you, Brendan. That's excellent. Thank you for responding to those questions. Thank you for those who participated, asked questions, and watched this webinar. That's the end of our webinar for today. We'll be adding the recording and slides to the website in the coming days, and keep an eye out for future webinars. But thank you very much, everyone, and thank you, Brendan, again, and goodbye.
Thank you. Thank you, everyone.